Hey, what's up, gamers? So today I have so many exciting things to share with you. I really believe that we all benefit from sharing our experience working on things and actually learn from each other's mistakes and, of course, also successes. The main reason why I started this project was to really learn in depth the Unreal gameplay ability system by doing and not by blindly following tutorials with pre-made scenarios, but by really going all in and build something where I had full control over every choice, every mistake, and every fix. By doing it solo, I got to focus on the code architecture. I could experiment freely and actually see the long-term effects of my code design choices. I had to deal with the consequences, good and bad, and think about how I could bring that experience and knowledge in a production environment. In the end, there is no magic pill. No matter your level, continuous learning and hard work is always the best way forward. Gas is incredibly powerful, but it takes time and true hands-on experience to deeply understand how it fits into a game's structure and reveal its true power. One of the biggest things that I took away from using Gas is how it really pushed me to think about architecture from the start. It's really not the kind of system you can just throw into a game without any planning. It really forces you to think in terms of modularity, separation of concerns, and scalability, which are things that really matter in a production setting. It's easy to throw a bunch of flashy features on screen that look good, but without a clean and organized high-level structure, finishing anything beyond a small, self-contained project quickly becomes nearly impossible. What I'm going to show you today is the first version of a foundation for an RPG game that I built using Gas, and most of the core logic is written in C++, and I use blueprints when they're clearly the better or the faster choice. I will now walk you through the main gameplay systems that I've built and how they come together through the Gas framework. Alright, now let's talk about the interaction system. It is built around an actor component that I called interaction actor component, and I placed it on the player character. The way it works is that it does a line trace through the crosshair on a custom interaction channel, and it is looking for actors that implement the interactable interface that I also created. And for an actor to be interactable, it just needs to implement the interface and set up what interaction means for that actor. It also needs to set its interaction type depending on if it needs to react to a simple collision interaction or if it needs active player input to react. In the case of input interactions, if the trace finds something, it will draw information about the interactable from a data table, and it will fill a prompt with the information and waits for the player to press the interaction button. And from there, everything is handled by the actor itself, because there is really no need for the interaction logic to know what each object does other than just saying, hey, interact. Also, I do make sure that the interaction trace does not tick every frame for performance reasons. It has to feel responsive, but at the same time consume the smallest amount of resources possible. There is a sweet spot that reveals itself after some testing, and that's really the direction I'm going for. The same goes for the custom trace channel. You really want to reduce the detection handling to the smallest set of actors as you can by really having every non-interactable actor ignore interactions detections completely. At first, I thought about having a common base class for interactables, but I quickly realized that it would greatly complicate the process of adding new types of interactables over time. It would not scale very well. In that case, an interface is to me the right tool for the job because it really gives you the power to transform any actor you want into an interactable with frankly minimal effort, and it greatly reduces coupling. I went for a Skyrim style interaction system because I have always liked the precision of selecting items through the crosshair when there are a lot of items around, like on a table as an example. It does create some weird situations in third person where you will expect to trigger an interaction by actually facing the thing. I will need to explore solutions here and refine the system over time. So now let's talk about the inventory system. The inventory is managed through an inventory component, which is an actor component, and I put it on the player character. It is designed to handle all the high-level logic of adding, removing, and finding items, as well as managing item categories. And instead of having one big container holding everything, I just created separate containers for each category to ensure that it does not get slow when there's a lot of items. Now, when it comes to managing items, there's a concept of an inventory item that I created. It's just a U object. So instead of storing items directly, I store U inventory item object. So that way, it's not just about holding an item reference. It's about holding all the necessary information like display names, stack amounts, descriptions, icons, and frankly, any other relevant data that you might need. This will keep the inventory system more flexible and decouples it from other systems like UI or equipment management. Now, let's say that you want to add a potion in the inventory. The inventory component will create an object of type consumable inventory item, which is a child of the inventory item base class, and it will add it to the right container. If the item is stackable, it will just increment the stack amount instead of creating a new object. And this design allows me to easily add new item types down the road if I want. And the key here is that every item knows how to manage its own logic. So the UI does not need to care what type of item it is. It just calls use on it, and the right logic will kick off behind the scenes when you want to use the item. If it's a consumable, it knows how to handle the logic for consuming. If it's an equipable item, the inventory items knows how to start the equip process. And all the item data that gets used to populate the inventory item when it is created is pulled from a data table, which keeps everything consistent and easily editable without having to touch the core code every time you want to add or change an item. It is very helpful for designers to have that kind of power so that they can change values easily without asking a programmer. What I like also about this setup is the flexibility of it. If I want any actor in the game to be able to hold items, things like a chest, a container, maybe a vendor inventory, all I need to do is just to slap an inventory component on it, specify the list of items I want it to hold, and then create the interaction logic for how the player can interact with it. And then this makes the system really modular and easy to extend to different types of objects. Okay, so let's talk about the equipment system. It is also based on an actor component that I call the equipment component. And just like the inventory component, it handles the high-level task. So things like equipping, unequipping, and checking if something like a weapon is equipped, and so on and so on. The equipment component is also part of the inventory flow because when you equip an item, the system will expect an equipable inventory item object to work with, so they are closely related in that matter. The inventory component receives the item, the equipable inventory item equips the item. One important concept that I added is the equipment slot. It is to accommodate different item types and different behaviors. So as an example, in my case, I have slots like main hand, offhand, and armor slots like head, legs, etc. So each equipable inventory item will be assigned to a specific slot. So when you try to equip something, the system will know where it should go, and it will check if there is already something in that slot, handle the removal of the old item, and then attach the new one to the character. Also, if the equipable has a gameplay effect, things like boosting some stats, it will apply those effects to the player character also. This allows for really easier management of the player's equipment, and also automatic updates to their stats, always based on what's equipped. And the same happens when you unequip an equipable, it will remove the stats. Okay, let's talk about UI. My main goal was to keep a clear separation between gameplay logic and UI logic. So I went with a take on the MVC pattern. Basically, I created widget controllers that act as a middleman between the UI and the gameplay systems. So the UI only knows about its controller, and the controller handles all the interaction with the gameplay side. It's working quite well, and it's keeping things clean, but I'll admit it sometimes feels a bit heavy in terms of code. There's a lot of moving parts, and I know there are lighter approaches out there, more modern way of doing it, and I'm planning to explore other options in the future to maybe simplify or replace that system. But overall, it's been a great learning experience, and it definitely gave me a better understanding of what clean UI separation actually looks like in practice. So now let's talk about gameplay abilities themselves. In my project, almost everything the character does is handled through gameplay abilities. Light attacks, heavy attacks, rolling, blocking, putting a weapon in hands, even death actually, they're all abilities. One of the best parts of GAS to me is how easy it is to control when abilities can or cannot be used. I can set things like required tags, blocking tags, cooldowns, and even resource checks. So just by using tags, you have full control over when you can use an ability and when you cannot. That kind of stuff can become really complicated if you don't have a system behind it. And in my case, as an example, you cannot attack while rolling, and that's just handled by the light attack ability that's checking for a tag that gets applied during a roll. So no spaghetti code, just clean, simple tag logic. It's also really easy to add or remove abilities based on the context. In my case, every weapon type grants a different set of abilities. So each weapon also has a special ability that only becomes available when the weapon is equipped and in hand. When that happens, the ability is added and it is removed when the player unequips the weapon. It also applies to animations. So different weapon types often needs completely different animation sets. So each weapon type is linked to an animation layer, and all of these layers share the same base, but inside each layer I define the actual animations used for that weapon abilities, along with its locomotion style. And just like the weapons abilities, I dynamically link or unlink the corresponding animation layer when the player puts the weapon in hands or removes it. That way, equipping a weapon does not just give you new abilities, it also gives you the animation style to match it. The setup plays really nicely with the enhanced input system too. I have a data asset for input configs that it will link each input action to a gameplay tag, like mapping IA underscore light attack to gameplay ability dot ID dot light attack as an example. Then I just tag my abilities with the right ID, and when an input fires, I use a function on my ability system component to activate the ability matching that tag. That way the input system will stay decoupled from specific ability classes, and it's super easy to plug in new inputs later. Okay, let's talk about the attribute set. To me, this is a massive game changer. In a lot of games, and not just RPGs, managing things like stamina, health, mana, crit, damage types, and all types of resistances, it really becomes a mess real fast when you don't have a clean and organized system behind it. And that's exactly what the attribute set will provide. So once you get the hang of the basics, it will really reduce the pain. As an example, in my case, it will handle the health, the max health, the special attack regen times, and all the resistances to the different damage types. At the moment I have 2 damage types, physical and fire. Its power really becomes more obvious when you pair it with gameplay effects. As an example, when you drink a potion, it just applies a gameplay effect that increases your health attribute. And when you equip a helmet, you can apply things like boost to resistance or armor, and it's all just data driven, it's clean, and it's easy to manage. And there's a lot more you can do with it. Things like duration-based effects for temporary things like curses or damage over time. Frankly, anything you need. It's really just about finding the right mix and making it happen. A good way to show how I'm using all this is by walking through how damage works in my current setup. This is just one of many ways to do it, and it's going to evolve over time, of course, but I'm happy with where I am right now. So let's say you're attacking with a fire-based weapon. All I need to do is link that weapon to a fire damage gameplay effect, and based on the weapon's base damage and the ability being used as an attack, I will set a magnitude on the effect. So when that gameplay effect is applied to the target, it will run through a custom calculation class. The goal of that class is to figure out the final amount of damage, so it will take into account things like crit chance, damage resistances of the target, anything that might influence the result for that specific damage type is calculated there. And then when the final amount is calculated, the attribute set will receive it, and it will apply the damage, check if it's dead, and broadcast all the necessary events depending on what's happening for UI, visual effects, audio, anything you need. It's a very powerful system, and it really helps keep the combat logic cleaner and more modular. Alright, that's a wrap for this devlog. This has been an incredible journey and a really massive learning experience. In the end, real progress always happens when you get out of your comfort zone and actively dive into things that you've never done before. And that constant learning and feeling of discovery is really what makes being a game dev the best job in the world. So keep working, keep persevering, and you will see great results build over time. See ya!